We have some brief vocabulary here to start with. I review real quickly here that population mean is mu and sample mean is x bar. We are going to talk in more detail about quantitative data. An outlier, if you have a set of quantitative data, an outlier is a data value or values that are markedly higher or lower than the bulk of the data. Recall that a mean is found by adding up all the data values and dividing by the number of data values. And I did note here that a mean is pulled towards any outliers, and we'll talk about that in a moment. Median is a value that has 50% of the data above it or equal to it, and 50% of the data is below it or equal to it. Standard deviation, we've talked about that in terms of the null distribution. When you click the summary stats button, it has told you the standard deviation of the null distribution. But we're now going to get in a bit more detail about standard deviation. If you had all the data, all the quantitative data from an entire population, the standard deviation for the entire population has the symbol sigma. And if you have just a sample of quantitative data, the standard deviation for your sample of quantitative data is called S. Recall, standard deviation is a number that tells us how far the data values are from the mean on average. And in the next video, we're going to get into more detail about standard deviation. In this video, I want to focus on looking at a few common distribution shapes and understanding where to locate and approximate the mean, median, and mode on those distributions. So first of all, on the left side, we start with the normal distribution, the bell-shaped distribution. And as we've already learned from our null distributions that always have this shape, the mean is right in the center on a normal distribution. The next easiest one to understand, I think, is the mode. Remember, a mode is a data value that occurs most frequently. So it makes sense that it would occur right here in the middle because that's the highest point on the distribution. So if you think about like a dot plot that would be used to create this shape, the data value right here would have the highest number of dots. It would be tallest number of dots, tallest vertical line of dots. So that must be the mode because it has the most dots. This is also, value right in the center is also going to be the median on a normal distribution, on a bell curve. I know that because 50% of the data is above that value and 50% of the data is below that value. So the middle value must be the median. Okay, so a normal distribution is kind of simple in that respect, that the mean, median, and mode are right in the middle. So now let's talk about a right skewed distribution. And it looks kind of like a normal distribution over here on the left side, except when you keep traveling to the right, it just kind of keeps on going. There are going to be one or a small handful of additional values up here on the right side. So it has this general shape to it. And again, keep in mind, this is like there was a dot plot that was creating this shape, right? That the data value that occurred most frequently seems to be right here at this peak point on the curve. So that would be the mode. The place where that distribution is highest is going to be the mode because that would be the value that has the most dots. Median would be probably the next easiest thing to think about. Median on a right skewed distribution on this particular graph would be about right here. And again, a median is found by thinking about where is the value that would have 50% of the data values below it and 50% of the data values above it. That would be about right here. Now it turns out on a right skewed distribution, the mean is always on the right of the median. In other words, the mean is higher than the median in a right skewed distribution. And the reason that makes sense is because these values up here, these high values on the right, pull the value of the mean to the right. A classic example of this is looking at maybe salaries at a fake factory. So for example, let's say a factory has a bunch of employees and the bulk of employees are making, like, they're working part-time and making $10,000 a year. And we have a whole bunch of people making that $10,000 a year salary. And then you have the CEO who's making $200,000 a year. So if you think about drawing out that distribution, down here you would have 10,000, and there would be 1, 2, 3, 4, 5 dots at a salary of 10,000. And then way up here is 200,000 with 1 dot. So this is an example, a real simple example of a right skewed distribution. The bulk of the data is over here on the left, and there's one outlier that is going to pull the mean to the right. So let's look in more detail at this. If we think, what's the mode of this? The mode would be 10,000. It's the data value that occurs most frequently. What's the median? It's also, in this case, 10,000. Half the salaries are above or equal to 10,000. Half the salaries are less than or equal to 10,000. But the mean, to find the mean, you have to add up all the data values and then divide by the number of data values. So when I add them up, I get 250,000, and I have to divide by 6 because there's 6 data values. And I get a mean of 41,666.67. So the mean here would be higher than the median. Why did that happen? Because when we calculated the mean, we had to add in this high outlier value into our calculation. But notice the median is only taking into account the data values and their order. So if I had that $200,000 salary and it had been $2 million salary way up here, that would pull the mean up even higher, but it really wouldn't even change the median at all. Median would still be 10,000 because half the data values would be above 10,000 or equal to it, and half the data values will be below 10,000 or equal to it. Whether this number is 200,000 or 2 million, or if he brought his salary way down, it would still be equal to 10,000 for the median. The mean, however, is dramatically pulled in the direction of that outlier because you have to add it into the calculation. The next example distribution we're going to look at is the left skewed distribution. You're going to have a 1 or a small handful of values on the left side, and these values on the left side will pull the mean to the left, but they don't really have much effect on the median at all. All right, so again, in the left skewed distribution, the mode is there at that peak point. The median's about here with half the values above it and half the values below it. And the mean is going to be pulled to the left of the median. In a left skewed distribution, the mean is lower than the median. A classic example of this is actually something that I see as a teacher. When students take exams, maybe I have students all come in and I get a whole bunch of students that get 80s. So I'll just get a real small class. Let's say we have 5 students that get 80s on a quiz or a test, and then 1 student doesn't show up at all, just skips test day and gets a 0. So thinking about that, I would have 80 up here that has 5 dots above it, and then I have 1 student down here with a 0, so there's 1 dot. So the mode would be here at 80. The median would also be 80. Because half the data values are above 80 or equal to it, half the data values are below 80 or equal to it. But the mean is going to be lower than 80. The mean, to calculate it, we're going to take 80s, all those 80s, and add them up. We also have to add in the 0. We divide by the total number of data values, which is 6. So when I add them all up, I get 400, and I divide by the total number of data values, which is 6. I got a mean of 66.7. So again, you see the mean is here at 66.7. It's lower than the median. That left data value down here pulls the mean to the left. So if I were to walk into that class the next day and say, all right, class, on average, the class got an average score of 66.7. That was pulled so far down by this one score. I might actually not do that. I might walk in there and it would be better for me to tell the class, hey, the median score in the class was 80. It doesn't seem fair to me that that one student score would be included in the average that I tell the students about. because that's one score is really having a dramatic effect on that mean, but it's not affecting the median.